Hi everyone, this is the first section of your next unit, which will be forces. So this is what happens when forces are applied at angles. So if you remember grade 11 physics, we did everything going left or right or up or down, but that's not exactly how everything works in physics. So what we're looking at today is two scenarios. One where a force is being applied at an upward angle. So that would be something like pulling a sled, or when the force is being applied at a downward angle. So it'll be like a shopping cart or something where you're pulling downward. So how do these work? Well, we're still working on that fundamental principle of Fnet equals forces to the right minus forces to the left, or Fnet equals forces up minus forces down. So with those concepts in mind, we still need to figure out a free body diagram. So this would be a free body diagram for an object being pulled upward. So this would be, and we're going to call this weight this year because that's what you're going to see in the future. Still going to call this normal force. This is still force of friction, and this is your applied force. But if I look at this, this is an angle, and you know we can't work with stuff at an angle, so using our logic from vectors, if I were to break this down, I would have part of my force going forward and part of it going upward. So we're going to call this Fay and this Fax. So it's similar to what we did in grade 11. Fnet is equal to all the forces that point in the positive direction, which is Fax, not just Fa, but the Fax, because it's this component that goes to the right, minus all the forces that go to the left, which is the force of friction. You'll recall that Fnet equals ma, that Ff equals mu Fn. The part that gets a little different here is that Fn is now different. Before we said Fn equals Fg, but for this stuff we have to look a little differently. We have to look at Fnet in the y direction. So I'm going to make that Fnet in the x. Fnet in the y direction is all the forces that point upward, which is both Fn and Fay, minus the weight which points downward. We know that we're not moving upward, so if I rearrange, the normal force in this case is equal to the weight minus Fay. And these two equations are the key. So still Fnet in the x direction, Fnet in the y direction now, but Fnet equals weight minus the force in the y direction. That's for objects moving with an upward or at the upward angle. If I look at the downward angle, which is this one, I'll label my forces again. So that's Ff against me, and I put it against me because this is my applied force, and since it's going downward, it makes sense to put it on this side. The normal force is still upward, weight is still downward. Remember that we still have to break this into our components, so this is Fay, and I'll put my other one in here. This is Fax, so this is Fax here, and this is Fay. If I do Fnet in the x direction, it's all the forces pointing to the right, so still Fax. All the forces pointing to the left, still Ff. Still the exact same equation. The difference is when I do Fnet in the y direction, so all the forces that are upward, below y there, Fn, and all the forces that are downward, minus weight minus Fay. Since this is 0, the normal force is equal to weight plus Fay. And if you look at it, these two are working together in this one, so both the weight acting downward and someone's pushing downward are increasing the normal force. And in this one, the Fay is acting against it, so it's actually kind of lifting it up and reducing the amount of force that's acting on the ground. that therefore the normal force is left. So these are our main equations. This is where they're derived from. I hope that helps, and I'll piece these together in an example shortly.